This is a presentation on using the one sample t-test when you have an interval variable to compare to a single score. You have, in other words, several scores, and you want to compare it to a single threshold kind of score. I'm Reginald York, professor in the University of North Carolina, Wilmington. At the end of this presentation, you will be able to employ the Excel file that I've created for calculating the one sample t-test for comparing the mean score of an interval variable to a single score, such as you have 10 post-test scores for clients, what their condition was like at the end of treatment, and you have a single score to compare that to. You will know how to use this file to determine the value of both t and p, which will help you in determining statistical significance. You will also know how to use this file to determine the effect size, which is an aid in determining practical significance. This means that you have data on a variable that is measured at the interval level. You have several scores, that is, on that, and you have a single score to compare it to. You might have, for example, post-test scores for 12 clients, and you have a mean pre-test score for them, but you don't have the ability to match each person's pre-test and post-test scores, so you're just going to compare this array of post-test scores to the single mean score for the pre-test. That's your one score you're comparing the post-tests to. That's one example. You wish to know if the mean score of the principal variable is different from the single score that represents some form of threshold for that particular variable. What is mentioned was the mean pretest might be the threshold you're comparing your post-test scores to see if there's a difference. You understand the value of p in statistics and basic concepts in statistics. That's one of my assumptions. Here's an example. You collected anxiety scores for 13 clients before and after treatment, but you were not able to match each person's pretest and post-test scores. So you can calculate the mean of these 13 pretest scores and use this mean score as the threshold score for comparison of the 13 post-test scores you have. So the data you will present in this particular spreadsheet, I'll show you in a few minutes, will be the 13 post-test scores and then that one mean pretest score. 13 scores compared to that one score. So if a mean pretest and 13 post-test scores, as I just mentioned. Another example, you're treating a single client for depression and you were able to measure depression one time before treatment began, and you have measured the client's depression score once each week for 5 weeks of treatment. So you have one baseline score before treatment and you have 5 treatment scores. The question becomes, are these 5 treatment scores taken as a whole significantly different from that one baseline score that was taken before treatment began? What the t-test does, the t-distribution is a little different from the normal distribution. It is used where the sample size is small and the population standard deviation is unknown. Thus it is very useful for human service evaluation, something that is the focus of these presentations I've done on statistics. It tells whether mean scores are significantly different, or in the case of the one sample t-test, whether a mean is significantly different from a single score. Your data, you have a single threshold score. You have several scores for comparison to the threshold. A really small number of scores like 2 or 3 is probably too small to use for this kind of test. The computer will do it for you, but you're probably setting yourself up for failure by having such a small amount of data to compute or to analyze. Statistical significance and practical significance. Statistical significance tells how likely our data will occur by chance. Practical significance is an opinion about the extent that our data is noteworthy. It is difficult to have practical significance in the absence of statistical significance given the basic meaning of failing to find statistical significance, meaning you have not ruled out chance. If you have not ruled out chance, how can you say you have meaningful information that can be of practical significance? Effect size helps with practical significance. The effect size is a score that represents differences in scores measured in regard to standard deviations. The greater the effect size, the greater is the difference. The mean IQ score is 100, the standard deviation is 15, so if your IQ score is 115, you are one standard deviation above the average for IQ. Effect sizes of 0.3 are considered low, 0.5 is considered medium, and 0.8 is considered large. The formula for calculating the effect size for the one sample t-test is the difference between the mean for the primary scores and the threshold scores divided by the standard deviation of the primary scores. So basically, this shows how many standard deviations of difference there are between the two. That is to say, between the threshold score and the treatment scores that you have there. I am going to go past this right now because I rethought that. Okay, you're now ready to use the York Excel file. You'll load the Excel file, the software, then you'll load the particular file, and we will get to that right here. Okay, York one sample t-test comparing interval variable with a single score. That's the name of the file that you will load here that I've created. You use this file to compare a single score entered in cell C8, which is right here, enter the threshold score there, to an array of scores entered in A6 through A56, starting right there, going right down the line to do all those scores that are being compared to this single threshold score. This is your value of t right here. Here is some guidelines in this regard. If your sample size is at least 3 and your t-value is at least 2.132, you have statistical significance at the 0.05 level. As you can see here, if the sample size is 4 and your t-value is at least 2.05, you achieve that same level of statistical significance. And you can look here, sample size of 5, t-value at least 1.9, etc. These are indicators that it says if the t is at least this, if your sample is at least this, and your t is at least that, then you have significance at this particular level. As you can see, the larger your sample, the lower your t-value needs to be in order to be statistically significant. So if you have back here 2.13 and you have a sample of 5, obviously that is significant because this is 5 is greater than 3. If you should ignore the negative sign if that comes up to be your t-value here as a negative sign. Just ignore that, it has no particular meaning. I hope this will be helpful to you.